in section 7.6, we're going to be talking about factoring again, and the process is going to be exactly the same, but this time we're going to see a lot of problems that do not have x squared in front. So there's going to be a couple things that we need to be looking for in order to work with a factoring problem when it's not just x squared in front. So let's look at this first example, 3x to the third plus 15x squared minus 18x. So I notice I don't have x squared, so it's not like the ones we've been practicing in the last section. So I need to break this down as best as I can. Now our first step you should always be looking for is a GCF. So if we have a GCF, that's the first thing we should always be taking out. So looking at 3, 15, and 18, I can see that I can divide all of these by a 3. And then I also want to take any x's if possible. And I see that I have a 3, a 2, and a 1 power on my x's. So I'm always taking my lowest power of x's. So I'm going to take x to the first out of all parts of my polynomial. So I'm going to put my GCF out front, and then I'm going to put in parentheses whatever I have left. So 3 divided by 3 would leave me with 1, and then x to the third divided by an x to the first is going to leave me with x squared. Then I have 15 divided by 3 is going to leave me with 5. X to the second divided by x to the first is going to leave me with an x, or an x to the first. And then negative 18 divided by 3 is going to leave me with a negative 6. And x to the first divided by x to the first is going to cancel, so I'm just left with that negative 6. So now that I've taken out my GCF, I see that in parentheses, I have a polynomial, or a trinomial, that starts with an x squared. So that's my second step, is try the box method to see if I can factor this any further. So I'm going to take the stuff that's inside my parentheses, and I'm going to see if I can break it down any further with that box method. So I know that this needs to multiply to be x squared. This needs to be multiplied to be negative 6. And then my diagonals need to add to be a positive 5x. So I'm looking for, first off, what multiplies to be a negative 6? Well, I have a couple options. Since I'm multiplying to be a negative, I would have to have one positive and one negative. So that could be a 1 and a negative 6, or a negative 1 and a positive 6. We could also have positive 2 and negative 3, or negative 2 and positive 3. These are all the options of what could multiply to be negative 6. So now I need to see, well, what multiplies to be x squared? That would be an x times an x. Then I want to try and see what's going to get me to become a positive 5x. You can try a couple options, but it looks like negative 1 and positive 6, because 6 times x would be a 6x, and negative 1 times x would be a negative 1x, and if I do 6x plus a negative 1x, that would add to be a 5x. So I have my solution right here and right here. So this factored to be an x plus 6, an x minus 1, and I can't forget that I took that GCF and I had it out front. So I need to put that out front of my answer. So this is my final answer. If you want to pause right now and try the next two examples on your own, do so now. Okay, now that you've tried these examples, let's go over it. So I always need to start off by looking for a GCF. So on A, I see that I can divide all of these by a 5. Now, looking at x's, I had an x squared, an x to the first, and that 50 did not have any x's. Since the 50 did not have any x's, I cannot take x's out. So I'm going to take that GCF out, and that's going to leave me with an x squared, a negative 7x, and a positive 10. So now that I've taken out my GCF, I'm going to have to try to do the box method. So I'm going to take whatever was inside my parentheses, and I'm going to put it into the box and see if it can factor any further. So that needs to multiply to be x squared. We need to multiply to be a positive 10, and our diagonals need to add to be a negative 7x. So let's figure out our multiples of positive 10. Since we're multiplying to be a positive, that's going to be a positive times a positive, or a negative times a negative. So that could be 1 times 10, or negative 1 times negative 10. We could also have 2 times 5, or negative 2 times negative 5. So all our options were laid out for us, and we had to figure out what was going to work to get us to be, well, first off, what multiplies to be x squared? That would be x times x. And then you probably tried a couple of the options, but landed on negative 2 and negative 5, because if we multiply this out, negative 2 times x would be negative 2x. Negative 5 times x is negative 5x. And if I add those two things together, it adds to be negative 7x. So my final answer was right here and right here, and we had that GCF, so I need to put it all together. So I had a 5, an x minus 2, and an x minus 5. Make sure you're putting all parts. All right, on B, we had to look for a GCF again. And it looks like I can take a 6 out of every part. And remember, we talked about whenever we have that negative out front, we have to take a negative out of everything. That's super important because it's really going to help us when we go to that box, so we don't have that negative x squared. That would be super hard to factor. Okay, so then I have an x to the third, an x squared, and an x to the first. So I'm going to take my lowest number of x's, which is x to the first. So I'm going to put that GCF out front, negative 6x, and that's going to leave me with an 1x squared, a positive 5x, and a positive 4, and those x's cancel. Remember, you're dividing big numbers and you're subtracting exponents. Okay, so now that I have my GCF taken out, I want to try to do the box method with what I'm left with in parentheses. So it looks like I got to multiply to be x squared. I have to multiply to be a positive 4, and those diagonals need to add to be a positive 5x. So I'm going to figure out what my multiples of positive 4 are. You could have a positive 1 times a positive 4, or a negative 1 times a negative 4. You could also have 2 times 2, or negative 2 times negative 2. So now that we have all our options, what multiplies to be x squared? Well, that would be an x times an x. And then you try multiple options, and it looks like positive 1 and 4 should work because 4 times x is a 4x. A 1 times x is a 1x. And if I add those together, it adds to be a positive 5x. So I have my solutions here. I have my x plus 1, my x plus 4, and that GCF that I can't forget about. So my answer would be negative 6x times an x plus 4 times an x plus 1. All right, looking at example 2. Now we need to do the same process over and over again, just like we've been doing on our other examples. So on this one, we need to first look for a GCF. And I have a 2, a 1, and a negative 21. So it looks like I can only take a 1 out of all of those, which dividing by 1 is not really going to change my polynomial. and I had an x squared, an x to the first, and then that negative 21 did not have any x's. So I can't take a GCF out. So since I have no GCF, I have to go straight to my box. Now this is going to look a little different than what we've done before because this is multiplying to be a 2x squared this time. We've never had that before. And we're multiplying to be a negative 21. And those diagonals are adding to be a positive 1x. So just like we've done in the past, we are going to have to do the same process. But we really need to keep in mind that we are multiplying to be a 2x squared. So that's going to have a play on what is putting into these two boxes on the diagonals. Because if we want to become a 2x squared, we would have to multiply that x times x, but in order to get the 2, we would have to have a 2 times a 1. So remember, that's going to make a difference in what's multiplying and adding to be that 1x. Okay, so multiples of negative 21. We could have a 1 times negative 21 or a negative 1 times positive 21. We could also have a 3 times a negative 7 or a negative 3 times a positive 7. So I need to try all of my options to see which one is going to work. Now, if you get it wrong the first time, remember that's okay. That's why we have erasers, and we can erase and we can try the next option. So I don't always love starting with the 1 times something because those a big option is that 21. So I'm going to start with something a little smaller. Let's start with a 3 and a negative 7. So let's see if that works and see what happens. So a 3 times a 2x would give me a 6x. And a 1 times an x would give me a negative 7x. Now, if I add negative 7x plus 6x, that's going to give me a negative 1x, which is super close, but I don't want a negative, I want a positive 1x. So it looks like I could change my signs, and let's see if that works. A negative 3 and a positive 7. So if I switch that around, it's going to give me a positive 7x and a negative 6x, which would add to give me a 1x. Now on these, the placement of our numbers does matter because our x's are not just x's anymore. So we could also have switched the place of the 3 and the 7 and seen if that made a difference. But we happen to find our answer. So our answer is an x minus 3 and a 2x plus 7. You could also write it as 2x plus 7 and x minus 3. Either one is completely fine. Okay, if you want to pause now to try the next 4 examples, pause your video now. Okay, so let's go over these now that you've looked at them. So on the first one, we had to look for a GCF, and we did not have a GCF. We could only take out a 1, which did not help us to factor any of it. So we had to go straight to our box method. So if I go straight to my box, I had to multiply to be a 2x squared, and I needed to multiply to be a negative 6. Those diagonals had to end up to add to be a negative 1x. So we first off, what multiplies to be 2x squared? Well, that would be a 2x times a 1x. Okay, then we needed to figure out what multiplies to be negative 6. Well, that could be a 1 times negative 6, negative 1 times positive 6, 2 times negative 3, or negative 2 times positive 3. So now that you had all your options, you had to try out what you thought would work. So, like I said, I always like to start with something that's not 1 in your number. I like to start with something else. It really doesn't matter, just my preference. So I'm going to try out the 2 and negative 3 first. So let's try negative 3 and positive 2. So negative 3 times 2x would become a negative 6x. And 2 times x would become a 2x. So if I check that, 2x plus negative 6x would become a negative 4x. So that looks like it didn't work. But remember, we can always try to switch our options around. We can still try that negative 3 and positive 2 to see if it works this way, because that 2x and 1x are making a difference on our placement. Okay, so let's try it this way. 2 times x will give me a 4x, and 1x times negative 3 is negative 3x. So if I add those together, negative 3x plus 4x would give me a positive 1x. So I'm getting closer. It looks like now I need to switch around my negatives. So let's try a negative 2 and a positive 3 this time. So if I do that, I'm going to get, let's see, let me erase my options that I had. Negative 2 times 2x would give me a negative 4x. And 3 times 1x would give me a 3x. So 3x plus a negative 4x does get me to negative 1x. So I found my answer. 2x plus 3 and an x minus 2. Or remember, you can always write it the other way. That is also correct. Don't get discouraged when you are getting a wrong answer. It doesn't mean you're doing something wrong. This is a process of trial and error, and that is okay. Okay, so let's try that next one. We need to look for a GCF first, and we should have found that we did not have one. So we needed to go straight to that box, and let me set it up for us. We need to multiply this time to be a 3x squared. So 3x squared would have to be a 3x and a 1x. Okay, so now let's see what multiplies to be negative 5. Well, that could be a 1 times a negative 5 or a negative 1 times a positive 5. Okay, so let's try our first option. 1 times a negative 5. Let's see if that works. So 1 times x is a 1x, and negative 5 times 3x is a negative 15x. That's going to be way too big to get me to be negative 2x. So that option did not work. I don't want to throw that one to the side yet because I want to switch these two around. Let's try the 1 here and the negative 5 here. So negative 5 times x would be negative 5x. And 3x times 1 would be a positive 3x. So if I add those together, 3x plus a negative 5x, that does add to give me negative 2x. So I found my answer. So 3x minus 5 and an x plus 1. Or you can always write it the other way. Alrighty, let's try these next two examples. So once you figured these out, you should have found that you, again, did not have a GCF. So you had to go straight to your box. So we had to multiply to be a 5a squared, multiply to be a positive 12, and our diagonals had to add to be 19a. Okay, so let's figure out what multiplies to be 5a squared. That would have to be a 5a times a 1a. Okay, then let's see what multiplies to be a positive 12. We could have a 1 times 12 or a negative 1 times negative 12. We could also have a 2 times 6 or a negative 2 times negative 6. We could have a 3 times 4 or a negative 3 times negative 4. Now I notice that in my polynomial, I had a 5a squared plus 19a plus 12. So there was no negatives in my original polynomial, so I don't think that these negative options are really going to help me out, which really helps to narrow down my options. Okay, so let's try out, let's do I'm going to start at the bottom, 4 and 3. So let's try 4 and 3. So 4 times 5a would have been 20a, and 3 times a would have been a 3a. That's going to give us 23a. So that one's not helpful, but we're not going to throw this option to the side yet because we can always switch around the 4 and the 3. Let's try the 3 here and the 4 there. So 4 times a would give me a 4a. And 5a times 3 would give me a 15a. If I add those together, 15a plus 4a does give me 19a. So I found that my answer is 5a plus 4 and an a plus 3. Okay, let's try our last example for this section. We need to factor this out, and you should have found there was, again, no GCF, so we had to go straight to our box. So once we set it up, we needed to figure out what multiplies to be 7. I'm running out of space, sorry. 7m squared. Well, that would be a 7m times a 1m. We also need to figure out our multiples for 28, negative 28. So we could have had 1 times negative 28, negative 1 times positive 28. We could have 7 times negative 4, or negative 7 and positive 4. And we could also have a 2 times negative 14 or negative 2 times positive 14. So we have a bunch of options. So let's look, and I see that, I don't want to start with the ones. Let's start with a 7 and a 4. So let's start with the 7 and negative 4. So 7 and negative 4. Let's see if that works. 7 times 1m is going to be 7m. And negative 4 times 7 is going to be a negative 28m. So if I add those together, negative 28 plus a 7 is going to give me negative 21. So that one did not work. So I'm going to erase these, but I'm not going to throw them to the side. I'm going to flip them around and see if it works the other way. 7 and negative 4. So negative 4 times 1m is going to give me negative 4m. And 7 times 7 is going to give me 49, and then I get an m. So 49 minus 4 would give me a positive 45. So I'm close. I need a negative 45. So let's see if switching my negative to the 7 would help out this situation. So let's see. So 4 times m would be a 4m, and negative 7 times 7m would be a negative 49m. If I add those together, it does give me negative 45m. So I found that my answer is 7m plus 4 and an m minus 7. Whoops. Remember, you can always write it the other way They both mean the same thing. Okay, let's look at example 3. We're going to keep practicing this and see how we do. So let's try it out. We always want to look for a GCF first, and I see that 37 is kind of throwing it off, so I don't have a GCF. So I'm going to have to go straight to my box method. 6x squared, a positive 6, and those diagonals have to add to be a 37x. Okay, now on the last examples, we were multiplying to be a 3x squared or a 2x squared or a 7x. So all those were prime, which means that they only have one option of what they multiply to be. They only could be 1 times 2 or 1 times 3, 1 times 7. But on this one, we have to multiply to be a 6x squared. So this makes it a little trickier. We have 2 options of what this could be. We could have a 1x times a 6x, or we could have a 2x times a 3x. So let's start off with just one option, and remember, we can always switch to that other option. So I'm going to start off with the 1x times the 6x. Remember, this is always just a game of guess and check. So that means that we also have the options to multiply to be a positive 6. So we could have 1 times 6, negative 1 times negative 6, 2 times 3, or negative 2 times negative 3. Now, our polynomial had only positives in it, so I don't think these negative options are going to help, which really helps when I'm going to do the guess and check to narrow down my options. So let's see. Let's be bold. Let's start with the 6 and the 1. So let's see if I start with a 1 and a 6 here. 1 times 6x is going to be a 6x, and a 1 times an x is going to, or 6 times a 1x is going to also be a 6x. So that's going to be way too small to add to be 37. So let's see if I switch these two around, if it gets me the correct answer. So a 1, oh wait, that's what I already had. Sorry, let's put the 1 here and a 6 here and see what happens. 1 times x is going to give me 1x, and a 6 times 6x is going to give me 36x. Oh, that looks nice. 1x plus 36 does give me 37x. So I found my answer is a 6x plus 1 and an x plus 6. Now remember, if we ran out of these working, we could have switched to 2x times a 3x. If you want to pause now and try the next 6 examples on your own, you can do so now. Alrighty, now that you've tried these examples, let's go over them and see how you did. So on this first one, we looked for a GCF and we did not find one, so we had to go straight to our box. So we had to multiply to be 6x squared. We had to multiply to be negative 6. And our diagonals had to add to be 5x. So again, we could have 2 different options to become 6x squared. We could have 1x times a 6x, or we could have 2x times 3x. This time I'm just going to start it off differently and see if the 2x and the 3x is our option, since we had 1x and 6x last time. Remember, you can always try different ones. There's not a best way to find it. You just got to guess and check. So in order to multiply to be negative 6, we could have 1 times negative 6, negative 1 times positive 6, 2 times negative 3, or negative 2 times positive 3. So we have a lot of options, and we have that option of negative, so we gotta try them all. Let's start with a 2 and a 3. So let's see if -2 and +3 are our option. So -2 times 3x is going to be -6x. And 3 times 2x is going to be 6x. Well, those would add to be 0, so that's not helpful. But let's see if I switch these two around and put the -2 here and the +3 there. And let's see if that does the trick. So 3 times 3x would be a 9x. And 2x times -2 would be -4x. So if I add those together, it does give me +5x. So our answer is a 2x plus 3 and a 3x minus 2. Or you could write it the other way, 3x minus 2 and 2x plus 3. But those x's with their numbers have to stay together. Alrighty, let's look at our next example. So we need to look for a GCF first, which looks like we don't have one. So we have to go straight to our box. So we have to multiply to be a 4n squared and a +4, and those diagonals have to add to be -17n. So let's figure out our multiples of 4. That could be a 1 times 4, a -1 times -4, a 2 times 2, or a -2 times -2. We also have to multiply to be a 4n squared. So that could be a 1n times a 4n, or if this doesn't end up working, we could also switch it to a 2n and a 2n. So we have multiple options. Let's try the 1n and the 4n first. So let's see. I know I'm not going to be using only positives on this because we have that negative in the middle. So let's try -1 and -4. So let's see if that works. Let's see. So -4 times 1n would be -4n. And -1 times 4n would be a -4n. Those would add to be -8n. So that's not going to work. But let's see if I switch the -4 and the 1 around, if that helps us out. So let's try a -4 and a 1 here. 1 times 1n would be a 1n, and a 4n times a -4 would be a -16n. Oh, wait, this needs to be a negative. We had negative times a negative, so this should be a -1n. So if I add those together, that would give me -17n. So my answer is a 4n minus 1 and an n minus 4. Or remember, you can always switch them around, but make sure that those numbers stay with the correct letters. Okay, let's try C. So we always need to check first for a GCF. And it looks like on this one, I can divide all of these by a 3. I can't take any x's out, but that's okay. 3 is going to help me out to give me a 3x squared, a +22x, and a +7. That's super nice. That now we can see if we can go any further with the box method from the stuff in the parentheses. Okay, so let's see if we put our stuff in parentheses into this box. Let's see if we can make it factor any further. And let's see, we need to multiply to be a 3x squared. So that's going to be a 3x and a 1x. And we need to multiply to be +7. So that could be 1 and 7 or -1 and -7. Now remember, we only had positives in that original polynomial. So I don't think these negatives are really going to help. So let's see, the 7 and the 1. 7 times 1x would be 7x. And 1 times 3x would be a 3x. Those would add to give me a 10, so that's not going to help. Let's see if I switch the 1 and the 7 around, if that helps me out. So let's put the 7 here and the 1 there. So 1 times 1x would be a 1x, and 7 times x would be a 21x, which does make my diagonal add to be that 22x. So I have to write my answer. Now remember, we took that GCF out in the very beginning. So we need a 3 out front. And then we had a 3x plus 1 and an x plus 7. Or you can write this the other way. 3 still out front, x plus 7, and 3x plus 1. Okay, looking at example D, we need to look for a GCF. I already can tell that I'm gonna have to do something because I have a negative out front, and I don't like that. I need to get rid of that negative and divide everything by a negative. And then I also see that I can divide everything in this by a 4. So I'm gonna take a negative 4 out. So that's gonna leave me with a 4x squared, a 15x, and a negative 25. So I always want to see if I can continue to factor this with my box for the stuff that's left in parentheses. So if I set up my box, I need to multiply to be a 4x squared, multiply to be a 25, and my diagonals are going to have to add to be a 20 or a 15x. So my multiples of 25 would be 1 and negative 25, or negative 1 and positive 25. We could also have a 5 times negative 5, or if I really switch that around, it would still be the same thing. So I got a couple options. Let's try, and I also need to multiply to be 4x squared. So, let's see, 4x squared would be a 4x and a 1x. Or if that doesn't work, we can always switch to 2x and 2x. I like this negative 5 and positive 5 option. Let's see if it works. Negative 5 times 4x would be negative 20x. And 5 times x would be a 5x. So if I add those together, it's going to give me a negative 15x. So I'm close. I'm really close. Let's try if I switch this negative. It would give me a negative 5x and a positive 20x, which would give me that 15x. So I found my answer. Remember, we had that GCF, so that negative 4 has to go out front. We have a 4x minus 5 and an x plus 5. We could also switch them around with that negative 4 still out front, and it's the same thing. Okay, last two examples. We are always starting off by looking for a GCF. On E, I see that I'm definitely going to have to get rid of a negative. But I also want to see, can I take anything else out? That negative 25 and negative 25 is nice, but 6 kind of makes it impossible to take anything more than a 1. So what I'm going to do is I'm just going to divide this all by a negative 1. It's going to really help me out when I go to do my box. Because look, now I have all positive options, which makes my options super nice. So let's see. I need to go to my box, and I'm going to have to multiply to be a 6g squared, a 25, and my diagonals need to add to be a 25g. So the multiples of 25 would be a 1 times 25, a negative 1 times negative 25, or a 5 times 5, or a negative 5 times negative 5. Now we just said that our polynomial in parentheses only has positives. So these negative options are not going to help. Now, I have a 6g squared that I need to multiply to b. So we have two options. We could have a 1g times a 6g, or we could have a 2g times a 3g. You could try either option, but I'm going to start off with this. We could always switch if it does not work. So let's try the 5 and the 5, because 1 and 25 is a big number. Okay, so 5 times 3g would be 15g, and 5 times 2g would be 10g. Oh, that does add to be 25g. So my answer, I have to put that -1 out front. I got a 2g plus 5 and a 3g plus 5. Or you could always switch it around and put the 3g plus 5 first and the 2g plus 5 second. Okay, last example. Let's look for a GCF first. A 4, a 15, and a -25. It does not look like I have any GCF. So I'm going to have to go straight to my box. So I got to multiply to be 4p squared, multiply to be -25, and I need to add to be a -15p. So let's figure out, multiply to be 4p squared. Now, we have two options, but I'm going to start with the 1p and the 4p. We could also, if it doesn't work, switch to 2p and 2p. Okay, we also need to figure out what multiplies to be -25. So that could be 1 times -25, -1 times +25, or a 5 times a -5. So options, I don't like to start with the ones, so I'm going to start with the 5 and -5. So let's see if that works. -5 times 1p is -5p. And 5 times 4p is a 20p. If I add those together, it gives me a +15. So it looks like I need to switch around my negatives. And that's going to give me a -20p plus a 5p, which does add to be -15p. So on this one, we did not have that GCF out front, so we just have 4p plus 5 and a p minus 5. Or you can always write it the other way as a p minus 5 and a 4p plus 5.